Hello, everyone. Welcome to my channel, Behind the Binary. In this lecture, I would like to cover one of the most important topics in Python, especially valuable for beginners who are just getting started with programming. This topic forms the foundation for writing effective Python code and helps in understanding how the language works. By focusing on this core concept, new learners will gain the confidence to write their own programs, troubleshoot issues more efficiently, and build a strong base for more advanced topics. Whether you're transitioning from another programming language or coding for the first time, this section will give you a clear and practical understanding of Python's essential features. Let's get into the topic. Python is a high-level, interpreted programming language known for its simplicity and readability. It was created by Guido van Rossum and first released in 1991. Python's clean syntax makes it beginner-friendly, while its powerful libraries and frameworks make it popular among professionals for web development, data science, automation, artificial intelligence, and more. Key features of Python include: easy to learn and use, supports multiple programming paradigms, procedural, object-oriented, functional, extensive standard library and vibrant community, cross-platform compatibility, runs on Windows, macOS, Linux. Overall, Python is a versatile language that helps developers write clear and efficient code quickly. In Python, we write comments using the hashtag symbol. We define functions using the def keyword. In the upcoming lecture, we will dive deeper into functions, data types, and other important features. Here, I'm creating a sample function named fntest. Inside the function, I'm using the pass statement. We will discuss in detail what the pass keyword does and how functions work in upcoming sections. We will discuss more Python features, including what functions are, what data types exist in Python, how many data types there are, as well as conditional statements, loops, and many other important concepts. I'm using an online compiler to demonstrate and evaluate this lecture. You can find the link to the compiler in the description below. Now, let's dive deeper into Python. Let's take a look at how Python syntax works. In Python, comments are written using the hashtag symbol. Python allows you to define variables without specifying data types. It uses dynamic typing. For example, you can directly assign a value like I equals 1, which creates an integer. Later, you can reassign I equals hello to make it a string. Python handles the type change automatically. The print function is used to display output on the console. Initially, it's an integer, and then I change it to a string. Python supports dynamic typing, which allows this flexibility. Now, let's take a look at the built-in data types in Python. We'll explore each one step by step. Python supports several core data types, including input numbers integer, used to represent whole numbers, whether positive, negative, or 0. It does not include any decimal points and is commonly used for counting or indexing. Sparkles string represents text and is enclosed in single or double quotes. Strings can include letters, numbers, symbols, or even spaces. They're used to store and manipulate textual data. Input symbols float. A float represents numbers with decimal points. It's useful for representing fractional values, such as measurements or financial figures. White heavy check mark Boolean. This type has only two possible values, true or false. It's used for logical operations, conditions, and decision-making in programs. Package tuple. A tuple is an ordered collection of items that cannot be changed after creation. It's ideal when you want to store a fixed set of related values, like coordinates or dates. Receipt dictionary. A dictionary is a collection of key-value pairs. Each unique key maps to a specific value, making it perfect for structured data like user profiles or configurations. Next, let's explore how to access and work with these data types in Python. To check the result of each data type we've created, we can simply print the variables. For integer, string, float, and Boolean types, we can use them directly in the program without any special handling. However, for a tuple, we need to access values using their index positions. For a dictionary, we retrieve values using their corresponding keys. Here, I'm accessing the value from the tuple using index 1. For the dictionary, I'm retrieving the value using the key name. As you can see in the output, the expected values are printed correctly based on how we access them. You can now observe in the output that all the values are printed as expected. The output displays the integer, followed by the string, then the float, boolean, tuple, and finally the dictionary value. And that wraps up the overview of Python data types. Now, let's see how to check the data type of a value or variable in Python using the type function. Understanding type and print functions in Python. In Python, it's often useful to know the data type of a variable or value you're working with. This helps you understand what kind of data is stored and how it can be manipulated. The type function. Python provides the built-in type function to check the data type of any object or variable. When you pass a variable or value into type, it returns the type of that object, such as int, str, float, bool, list, tuple, dict, and many more. For example, if you want to know whether a variable is an integer or a string, you can simply use print type variable. This prints the data type of variable in the console. Why are type and print important? Debugging. When writing or testing code, you might need to check if variables contain the expected data type. Learning. Understanding what type of data you're handling helps prevent errors. Output. Using print lets you communicate with the user or verify your program's behavior. Summary. Use type to find out the data type of any object in Python. Use print to display information in the console. Together, they're powerful tools for learning, debugging, and interacting with your code. Now, you can observe in the output that it displays the data type of the variable. In this case, it shows that the variable is of type dict, dictionary. Knowing the data type of a variable while working on real-time projects helps improve code efficiency and reduces the chances of bugs. Similarly, we can check the data type of an array or list in Python using the type function. In Python, arrays are most commonly represented by lists, which are ordered collections of items that can hold elements of different data types. Using the type function allows us to confirm that the variable we are working with is indeed a list. Let's take a look at Python operators. Python supports various types of operators. Arithmetic operators perform mathematical operations like addition, subtraction, multiplication, and division. Comparison operators used to compare values. Logical operators used to check conditions by combining multiple expressions. In this example, let's see how these operators work. I am performing multiple arithmetic operations and printing the results to the console to check the output. Operators in Python are symbols or keywords used to perform operations on variables and values. Python provides a rich set of operators to perform different kinds of tasks, such as arithmetic, comparison, logic, and more. You can now see how the comparison operators work based on the output. They are used to compare two values or expressions and return a Boolean result, either true or false. These operators are commonly used in decision-making statements like if, while, and loops, helping control the program flow. Let's understand how these operators behave allows you to write conditional logic, like user access, validations. To perform data filtering in loops and functions. To create intelligent branching in your code. These comparison results are especially useful when combining with logical operators like and, or, and not to create complex conditions. Logical operators are used to combine multiple conditions, expressions, and return a Boolean value, true or false, based on their evaluation. They are most commonly used in decision-making statements like if, while, and for loops. Logical operators help you write more flexible and powerful conditions by combining or inverting expressions. They're essential in writing smart, readable, and efficient code logic. Logical operators let you combine or modify conditions. They return true or false depending on how the conditions evaluate. Let's take a look at loops in Python. Loops are a powerful feature in Python that allow you to execute a block of code multiple times without having to write it again and again. This is useful when you want to perform repetitive tasks like printing values, processing items in a list, or running calculations. Python supports two main types of loops. While loop runs as long as a given condition is true. For loop, iterates over sequences like lists, strings, or a range of numbers. First, let's explore the while loop. A while loop continues to execute its block of code as long as the condition evaluates to true. If the condition becomes false, the loop stops running. Here in this example, we initialized I equals 5. The while loop checks, is I greater than or equal to 0? If yes, it prints the current value of I, then decreases it by 1 using I dash equals 1. This loop will run 6 times, printing values from 5 to 0. Let's take a look at the for loop in Python. Python's for loop is used to iterate over a sequence like a list, tuple, string, or a range of numbers. Unlike other languages where you write for, I equals 0, I less than n, I plus plus, Python's for loop is more readable and directly works with items in a sequence. It is ideal when you know beforehand how many times you want to loop. Example, using range. Let's say we want to print numbers from 0 to 4, i.e., 5 times. We use Python's built-in range function, which generates a sequence of numbers. Let's take a look at data structures. Data structures are ways of organizing and storing data so that it can be used efficiently. Python provides several built-in data structures, including list, tuple, set, dictionary. Let's explore each one with examples. Small blue diamond list, ordered, mutable collection. A list can hold multiple data types such as strings, numbers, or even other lists. Lists are mutable, meaning you can change, add, or remove elements after the list is created. Elements in a list are ordered and can be accessed using index numbers, starting from 0. Let's take a look at a list example. In this example, we'll explore how to create a list, check its length, and perform common operations like accessing elements, appending, and removing values. In this example, we start by creating a list of string values. To find the length of the list, we use Python's built-in len function. When we print I0, it shows the first element of the list. The initial length of the list is 3. We then use append to add a new item, mango, to the end of the list. The remove function is used to delete an item by value, not by index. Here now I'm appending new value to the list which will append at the end, you can see in the output. Now the length became 4 and printing the value I of its index. Now, let's take a look at the remove function. The remove function in Python is used to delete an item from a list by its value, not by its index. If you try to pass an index number as an argument to remove, Python will throw an error because it expects a value, like apple, not a position, like 0 or 1. You can observe in the output that an error is raised when an index is mistakenly passed to remove. This is because Python looks for a value that matches the index number, which often doesn't exist in the list. Now you can observe the output after correcting the remove function. When we remove an item by value, the length of the list decreases by 1, as one element is removed. We can then print the remaining items using their index positions. But what if you want to remove an item by its index? In Python, if you want to remove an item by its index instead of its value, you should use the pop function. The pop function removes the item at the specified index and also returns the removed value. If no index is specified, it removes the last item by default. As you can see, the item at index 0, apple, was removed. Now the item at index 0 is banana. Let's take a look at tuple. In Python, a tuple is a built-in data structure designed to store multiple items within a single variable. It functions similarly to a list in that it maintains the order of elements. However, the key distinction lies in its immutability. Once a tuple is created, its contents cannot be altered. This means you cannot add, update, or remove items from it. This makes tuples ideal for scenarios where data integrity is important and you want to ensure the values remain constant throughout your program. Tuples offer several beneficial characteristics. They preserve the order of the elements, so the sequence in which items are inserted is the same when accessed. Despite being immutable, tuples allow duplicate values, and they can also store different data types together, such as strings, numbers, booleans, and even other collections like lists or other tuples. Because of their immutable nature, tuples are often used to protect data from accidental modification. Using tuples can be particularly advantageous in specific situations. For instance, if you're working with data that should not change, tuples provide a secure way to store it. They also offer better performance than lists in terms of speed, especially when dealing with large datasets or when iterating over elements. Additionally, tuples can be used as keys in dictionaries because they are hashable, unlike lists. Another common use case is in functions that need to return multiple values. Tuples allow you to return a structured group of values efficiently and cleanly. Let's take a look at dictionary. In Python, a dictionary is a powerful and versatile built-in data structure that allows you to store data in key-value pairs. Unlike lists or tuples, which are ordered sequences of items, dictionaries are designed for fast data retrieval by key. Each item in a dictionary consists of a key and a corresponding value. The key must be unique and immutable, such as a string, number, or tuple, while the value can be of any data type and may be duplicated. Dictionaries are unordered prior to Python 3.7, meaning that items are not stored in a specific sequence. However, starting from Python 3.7, dictionaries preserve the insertion order of items, although this behavior should not be relied upon for logical correctness unless explicitly required. One of the key advantages of dictionaries is their efficiency. They allow for extremely fast access, insertion, and deletion of values when the key is known. This data structure is especially useful when you need to map one set of values to another, like names to phone numbers, usernames to passwords, or words to definitions. Python dictionaries are also mutable, so you can add, modify, or remove key-value pairs after the dictionary is created. To retrieve a value, you use its key, making data lookup intuitive and clean. Another powerful feature of dictionaries is the ability to nest them, meaning you can store other dictionaries, lists, or even tuples as values inside a dictionary. This makes them ideal for representing complex, hierarchical data structures like JSON objects. Overall, dictionaries are an essential part of Python programming and are widely used in applications involving configuration data, database records, object representations, and more. Their flexibility and performance make them a go-to choice for handling structured data efficiently. Let's take a look at set. In Python, a set is a built-in data structure used to store an unordered collection of unique items. Unlike lists or tuples, sets automatically eliminate duplicate values, ensuring that every element is distinct. Sets are particularly useful when you want to perform operations involving membership testing, removing duplicates, or working with mathematical set operations like union, intersection, and difference. One of the main characteristics of sets is that they are unordered, meaning the items have no fixed position and cannot be accessed using an index. This also means the order in which items are stored or printed may not match the order in which they were added. Additionally, sets are mutable, so you can add or remove elements after the set has been created, but the elements themselves must be of immutable data types like numbers, strings, or tuples. Sets are often used when you need to filter out repeated entries from a sequence or check whether an item exists in a collection. For example, converting a list to a set is a quick way to remove duplicates. Python provides built-in methods such as add, remove, and discard for modifying sets, and methods like union, intersection, and difference for performing set theory operations. Another benefit of using sets is their efficiency. Checking whether a value exists in a set is typically faster than doing the same with a list, especially as the size of the collection grows. However, because they are unordered, sets are not suitable for situations where the position or sequence of items matters. In summary, sets in Python are best used when you need to manage a collection of distinct, unordered elements, and especially when working with membership tests or mathematical operations on groups of data. In Python, even though sets are unordered collections of unique elements, they are mutable, which means you can still add or remove elements after a set has been created. Python provides a few simple and effective methods for modifying a set, most commonly through the use of the add and remove functions. To add an element to a set, you can use the add method. This method inserts the specified element into the set, but only if it's not already present. Since sets do not allow duplicate values, adding an existing item has no effect, it won't raise an error, and the set will remain unchanged. This behavior is particularly useful when you want to ensure that your collection contains only unique elements. Let's take a look at functions. In Python, a function is a block of organized and reusable code designed to perform a specific task. Functions help make programs more modular, readable, and maintainable by grouping related logic into a single unit. Instead of writing the same code repeatedly, you can define a function once and call it whenever needed. In the example below, I have created a function named fntest that accepts an argument called name. Inside the function, it simply prints the provided name. In the output, you can now observe that it prints, "Hello, Bob." This is done by concatenating strings, which means joining multiple strings together. In Python, you can use the plus operator to append, combine strings. Let's understand how Python modules work. A module in Python is simply a file that contains Python code, such as functions, classes, or variables, that can be reused in other programs. Modules help you organize code into separate, manageable files and allow you to reuse functionality across multiple projects without rewriting it. Python supports three main types of modules. Built-in modules, these come with Python by default, e.g., math, random, datetime. User-defined modules, these are Python files that you create yourself to hold reusable code. Third-party modules, these are external packages installed using tools like pip, e.g., numpy, pandas, requests. Example: using a built-in module. In this example, we're using Python's built-in math module to calculate the square root of a number. In the output, you can observe that the square root of 16 is printed as 4.0. This demonstrates how you can leverage built-in modules to perform complex operations with minimal effort. File handling and exception handling in Python. Let's take a look at file handling and exception handling in Python, two essential features for building robust and reliable programs. File handling in Python. File handling in Python allows you to read from and write to files on your system. It is especially useful when working with data stored in external files like .txt, .csv, .json, and many others. Whether you're saving user input, reading configurations, processing reports, or generating logs, file handling is a vital part of programming. The basic steps in file handling include opening the file using the open function, performing operations such as reading, writing, or appending, closing the file using the close method, or better yet, using a with block which handles it automatically. Python supports various file access modes, including R. Read mode is default mode, used to read files. W. Write mode, which overwrites the file if it already exists. A. Append mode, which adds data to the end of the file. B. Binary mode, used in combination with other modes like RB or WB for binary files. Using A with open block is recommended because it ensures the file is properly closed after its sweet finishes, even if an error occurs. Understanding try and except in Python. Let's now take a look at how Python handles errors using try and except blocks. In Python, the try block allows you to test a block of code for errors. If an error occurs during execution, Python immediately jumps to the corresponding except block, where you can handle the error gracefully, without crashing your program. You can also specify the type of exception you want to catch. For instance, when working with files, a common error might be file not found error, which occurs if the file you're trying to read doesn't exist. In this example, the code in the try block attempts to open and read a file. If the file doesn't exist, the file not found error is raised and caught by the except block. You can also define a default exception handler by using except exception as E. This catches any error that wasn't specifically handled earlier. It's useful for logging or debugging unknown issues. By combining specific exceptions and a general fallback handler, your programs become more robust, user-friendly, and easier to debug. Let's understand classes in Python. A class in Python is a blueprint for creating objects. It allows you to group data, variables, and behavior, methods, into a single unit. Classes are a key concept in object-oriented programming, OOP, which helps structure code in a more organized, reusable, and logical way. Why use classes? Code reusability. Define once, create many objects. Encapsulation. Bundle data and behavior in one place. Modularity. Keep code organized and maintainable. Scalability. Great for building larger, complex systems like web apps or games. Class versus object. Class, a blueprint, like a design for a car. Object, a specific instance of a class, like an actual car built from the design. In this example, a class named person has been created. Inside the class, a method called greet is defined to print the name of the person. The class also includes a special method called __init__, which is known as a constructor. This constructor is automatically called when an object of the class is created. The constructor accepts a parameter called name, which is assigned to an instance variable using self.name. This instance variable can then be accessed by other methods within the class, including the greet method. This design allows the class to store and reuse the name provided when the object is created. To use the class, an object is instantiated by passing a name as an argument to the person class. This name is received by the constructor and stored in the instance. After the object is created, the greet method is called using that object. The method accesses the stored name and prints a greeting message that includes the name. This demonstrates how classes encapsulate data, like the person's name, and behavior, like the greeting, together. It also shows how constructors initialize the object state, and how instance methods can use that state to perform actions. In this example, the goal is to demonstrate how string concatenation works in Python using formatted string literals, also known as f-strings. When we want to include variables inside a string, we can use f-strings to make the code cleaner and more readable. To use an f-string, we place the letter F before the opening quotation mark of the string. Inside the string, we use curly braces to embed the variable directly where we want it to appear. For example, instead of concatenating strings using the plus operator or using functions like str, we can write something like f, hello, name. This will automatically insert the value of the name variable into the string. This method not only improves the clarity of the code, but also avoids common mistakes in type conversion and manual spacing. It's a modern and recommended approach introduced in Python 3.6 and is widely used for generating dynamic strings in Python applications. In Python, we can also import modules and use their functionalities within a class. This allows us to extend the capabilities of our classes by utilizing pre-built functions from standard or third-party libraries. For example, in the case of mathematical operations, Python provides a built-in module called math. By importing the math module, we gain access to a wide range of mathematical functions, including square root, trigonometric operations, logarithms, and more. Within a class, we can call any function from the math module by prefixing it with math. For instance, to calculate the square root of a number, we can use math.sqrt value. This approach promotes code reusability and modular design.